Alright, it's no secret that if you want to build a really cool desktop application, you need to have one of these things. Hi, my name is Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. What's the number one thing that your cool, fancy desktop application needs? Well, a splash screen. And okay, maybe not the best, most important thing that your application needs, but it's really cool to be able to have a splash screen at the startup of your app, and that way not only can you captivate the user's attention, you can get some loading done at the same time. In this video, I'm going to walk through a basic WPF tutorial where we can get a splash screen going, and we're going to look at some of the most common issues that I see when doing this type of thing, and that's going to be threading. If that sounds interesting, remember to subscribe to the channel and check out that pinned comment for my courses on Dome Train. With that said, let's go build us a splash screen. So to start things off, I'm going to jump over to my splash window that I've created. It's just a big magenta window. That's definitely going to get people's attention. I obviously don't recommend doing this. You probably want to put a picture or something else in place, but I do just have this progress bar set to be indeterminate so that we can see that it's not frozen. We have a screen up, but I didn't have any cool graphics to go drop in place here, so we're not going to be focusing on that. You can go style this thing up however you'd like, but I just wanted to call out that I do have this window that I've added, and a couple other things to note are that I have the startup location to be center screen, and that's going to mean that when we open this window, however we decide to do that, it's going to be at the center of your screen, as it might indicate. Otherwise, you might have some weird behavior where the startup location, you'll notice that the splash screen kind of comes up in different spots. I think usually it's where the cursor is, but something to pay attention to if you want it to feel a little bit more pro. The other thing to mention is that I have the window style set to none, so you can see that there is no control bar at the top of this window. You can't X out of it to close it. It's just going to be a borderless template that we can work with, and that way, like I said, you can go slap an image onto here and make it look super cool. So if you want to see how we end up building this with actual progress, stay right to the end of this video and you can see how to hook that all up. Okay, so we've seen that we have a very basic splash window, and if you notice in the left Solution Explorer that I have a main window XAML file as well. So what we're going to be doing is chaining our application startup to launching the splash screen, and when that's done, we're going to go launch the main window right after that. Now, a couple of things that I want to talk about in terms of the goals of our splash screen in this video are going to be one, that I want to make sure that we can run some background work, because that's one of the primary purposes that we have splash screens for. We need to do some work up front to get things set up, and that way we're not basically blocking the user interface and the user's kind of sitting there like, why the heck do I have this ghosted application that, it's locked up, I can't move it around? So we can go do some work, right? So I want to do that. The other thing is that we might want to have a graphic or something. Maybe it's just to, like I said, catch their attention. So you do want to have it there for some amount of time, but maybe once the work is done, you can let them X out of that splash screen, right? So I want to talk about these two concepts of having maybe some minimum amount of time you want to wait, and then also some work that you want to be doing. So we have these two things that we have to wait for. And once that work is done, maybe we can just say, okay, the user's waited long enough, let's let them X out of this splash screen and go to the application. So at the very beginning of my application, if you've watched my previous videos, I am using Screwdoor, I am using the iService collection for dependency injection, and I'm setting up a service provider. But if you want to learn more about that, you can go check out these videos, and that way you can catch up on this series. But it's not super important. You can go new these things up and create them however you'd like. This is just my preferred way. If we jump over to our startup method and we see how we want to go get this splash screen going, what I'm going to be doing is using what I call a presenter. And if you're working with different UI frameworks, you'll be familiar with things like MVC, Model View Controller, MVVM, Model View, View Model, and there's all sorts of other things you can do. I like to use something that I call presenters. They're going to be sort of our logic for getting our flow in our user interface. So I have a presenter that's going to be sort of the entry point that we're working with here, and I'm going to ask that splash presenter to show the splash screen. And a couple of things that I want to point out here on the API, and of course I'm going to walk through this in more detail, are that I have this show splash async method, so we're going to await that. I have a time that we want to show the splash screen for, and after creating this, I wonder if maybe this should say maximum splash screen time. So this is going to be something we talk about waiting for this work, which is the next part. We want to wait for this work to finish, and I'll talk about this comment because As I said in the beginning of this video, this is going to be one of the trickiest parts that I see that we have to navigate when we're building things like splash screens. But really, these are the two main things that we have on our splash screen. We have to wait some amount of time for the splash to be up, but we also don't want to let the user close that splash screen if we're still doing important work. Let's go jump into the implementation of show splash. To start off, this presenter does take in a few variables, so I am going to talk about this dispatcher a little bit later. That's going to be a bit of a spoiler alert for some things that are up and coming, but I do need a splash window reference. That's going to be the window that we saw at the very beginning of this video, that big magenta one, so I need a reference to that. This will get passed in through dependency injection in my current setup. I also need a main window presenter. If you don't want to use this presenter pattern, you can just go ahead and get a reference to the main window when new it up, or you could new it up inside of your splash screen presenter to show it. I am using dependency injection for all this stuff. It's my preferred way to do it, but this part here is going to be the thing that allows us to go show the main window after. And like I said, I'm going to come back to the dispatcher when we start coming across that throughout this tutorial. But again, if we go look at the show splash async method, we'll see that we have that time we want to wait, and we have our callback for doing some important work. So from here, let's go dive into the details about how we make these things run together and do them successfully. The first thing that I want to have, and I'm going to come back to this in a moment, is I have to make this cancellation token source. And that's because when we want to go have that delay that we're just waiting for the splash screen to be up, we need to be able to cancel that if the user clicks in time. So say that work finishes, we've done all of our heavy background work, and that only took 3 seconds, let's say, and we were supposed to wait up to 5 seconds for the splash screen. If we want to let the user close the splash screen earlier, so sometime between that 3 and 5 second mark, we do want to make sure that we can cancel that wait period, which we're going to look at in just a moment here. I am going to have to hook up an event for when that window is closing, and that's going to mean that once that window is closed, our splash window, that way we can cancel the wait period if it's still going, right? And then at the end, we can also make sure that we go and show the main window, because that was the whole goal for after the splash screen. So we hook that up when the splash window is closing. Right after that, we're going to show the splash window. So at this point in time, after line 118 runs, we have a splash window that should get presented to the user. Before we move on, this is just a reminder that I do have courses available on DomeTrain if you want to level up in your C# programming. If you head over to DomeTrain, you can see that I have a course bundle that has my Getting Started and Deep Dive courses on C#. Between the two of these, that's 11 hours of programming in the C# language, taking you from absolutely no programming experience to being able to build basic applications. You'll learn everything about variables, loops, a bit of async programming, and object-oriented programming as well. Make sure to check it out. This is where we have to go run our other work, and that's going to be between the minimum wait period that we want to set, as well as down here, I have the work that we want to go do in the background. So these are two different tasks that we have to work with. And the way that I've structured this, I want to explain, because you'll see that I have a task set here, but I'm not awaiting it at line 121. I'm actually awaiting it all the way down at line 165. So that's a little bit weird, right? Why do I have this one created up here, but down here is when I'm awaiting it? And to explain that, I want to talk about these two things competing, right? Because we could think about doing something like await task when all, and then we would pass in both of these tasks. So we have the minimum wait task, and then we would have the other one that's the, let's call it just the do work task, which I don't have, right? But conceptually, do we want to wait for both of these to finish until the end, right? And I'm going to write it out like this. If the minimum wait task is supposed to be 5 seconds, and like I said, the naming is probably wrong at this point. It might be like max wait time. So the max wait, and then the time it takes to do work, time to do work is only 3 seconds, let's say. What we want to be able to do is minimally wait for the work to get done. So we minimally need to wait 3 seconds. And then between the 3 and the 5 seconds, that's when we have this period where the user should be able to close the splash screen. And how I've accommodated that, you'll notice on line 167, I'm switching the splash window style to be from none, which I talked about in the beginning, to tool window. That's going to give us that little X in the top. You could do other things, and left a comment here talking about bindings and view models and stuff like that. You could instead have a button or something on the splash window, or make it so you can click somewhere on the splash screen or press escape and it handles this the same way. That's where you're going to want to configure it here. I'm just using the X in the top corner just to keep it simple. But the point is that if we were to wait for both of these things, we're always going to wait the maximum amount of time. And that means that we don't get that option to be able to X out earlier. We don't want a when all, but we want to wait until the work is done. If the work is done, we're going to, like I said, allow the user to interact with this splash screen to close it off however we want to do that. And then at the end, if the user has not interacted with the splash screen, we want to wait that remainder of the time. So again, minimum wait task, maybe not the best naming. Maybe it should be maximum wait because it's truly the maximum before we go and do that. So I'm going to go ahead and rename this because I think it's going to make it a little bit more obvious as we go through the rest of this. So I'm going to call this maximum splash time as well. The point that's important to note here is that if the time it took to do the work was greater than the splash time that you're setting, it's still not going to be the max, right? It's actually like the max idle time or something like that. The other thing I want to call out right at the end here on line 165 that's kind of weird, this is a bit of a cheat, I guess. I don't want to throw an exception when this task gets canceled because that's one of the things that can happen up here, right? Line 115 can cancel that wait task. And if you see here, we use that cancel token source. We use the token for that. I didn't explain this in detail, so I'm going to come back to this in just a moment. But because this cancellation token can get triggered from here, down here, this task will throw an exception if it's canceled. So this continue with syntax is a bit of a cheat. It's going to swallow that task cancellation exception. The dangerous part about this is if that task threw an exception for any other reason, it's also going to get swallowed. It's just because this is super lightweight right now that I'm not super worried about that. But a better way to do this would be, and it's a little bit gross to look at, but if you wanted to do something like this, we know that this task can get canceled, so we don't care. It's just that the behavior for tasks in .NET when you do a cancellation is that it's going to throw. So that's the goal of what this is to do, is we just don't care if it was actually canceled. We just want to continue on. Now to talk about this, because this part's important, we do want to have a delay. And like I said, we're going to be using our linked cancellation token. So it takes in the cancel token that was passed in, but we're going to make a new source. And that way they're linked together. If someone on the outside cancels, this thing will get canceled. But we also want to make sure that we can trigger cancellation ourselves. That was back here on line 115. So that's the token we're using here. It's important to note. But I have this continue with on here as well. So if we do reach the end of this, you'll see that it's only when it ran to completion. So if nothing else cancels this, there's no exception, whatever, it ran successfully to completion, we're going to close that splash window. As a result, this event will get triggered and we're going to continue on. To put this all together, and we're going to go jump into this part in just a moment from line 158 to line 160. So to put these pieces together, we have this delay task, and that's going to make sure that we can keep the splash screen up for an amount of time. And we also have this task that's going to be doing background work. I already explained the details about how we want to wait for that background work to be done before the user can go close the splash screen, but we have to go run these two things in parallel. Those are some of the nuances that we have to think through for both of these things, but now we have to go look at how this callback works. So I want to explain this a little bit further. This do heavy work async callback, if I scroll up to where this was called, this logic here is if you wanted to do some loading, right? So if you need to load resources up, connect to different things, whatever it happens to be, restoring state for your application, you have so many different options for things you could do here, but if you need some setup code to run at the beginning of your app, this is where you'd want to do it. Now, I'm going to talk about this assertion here, and I want to put this back in the code, because when we go to run this, I want to talk about what's happening. The important thing here is that this is background work. We want to make sure that whatever loading we're doing is happening on the background thread. If not, what will happen is that you will be using the user interface thread, the main thread, to do work, and that's not good, because as you are doing heavy work on this thread, you could be locking up the user interface. You get that ghosting behavior. It's kind of choppy if someone's trying to move the window around. We want to enforce that this is on the background, so I have this debug assert for us to prove if that's the case. A spoiler alert, for the rest of this video, we're going to be looking at all of the different situations, how this stuff is currently broken in everything that I showed you. From there, we're going to go fix it. To start off, let's go run this and see where the first issue is. What I'm going to do is start with a breakpoint though. So when we go show splash screen, I'm going to have a breakpoint right here so we can see how things come together. Let's go try it out. All right, as we step through things, there is no splash screen shown yet, which is as expected. We haven't hit line 118. So I'm going to go make that linked cancellation token source. We'll hook up our event handler on the closing of the window, and then we're going to go show it. So at this point, you might have seen very quickly, and I can't actually bring it up on my screen because we're stepping through the code, but the splash window popped up very briefly. It is sort of in the background right now. That's okay. So it did get shown, but now we have to go set up this maximum wait task. I changed the name. From there, we're also going to do the background work. So I'm going to go ahead and run this. I'm going to put a breakpoint here, and we'll see what happens. And as soon as I pressed F5, it might not have been obvious, you might not have heard the click on my keyboard, but when I pressed F5 to continue this, we hit this assertion. The tricky part about what's happening here is that this assertion is catching an issue for us. The assertion says that we need to be on a different thread than the current user interface thread. Checking the dispatcher, which is that thing I talked about earlier, so we're going to come back to that. The dispatcher is what allows us to run things on the main thread. So all of the user interface in WPF, even WinForms and other user interface frameworks, there's generally a main thread that runs for the UI. This dispatcher thread is the main thread. It's the UI thread. So what I'm doing is saying, look, we need to be on a different one. So when I pressed F5, it ran right to here, and it basically said, look, you're on the main thread. Stop. This isn't right. So how do we make sure that we don't get stuck on the main thread? Let's go back and see where we came from. Right here, line 158, something about this is wrong. We're basically saying, await, do this heavy work, and we're going to basically invoke this call to go run that method. But the problem is that this is running on the main thread. So let's go fix it. The code on my screen right now is a little bit more verbose. I've left in the original code here. You'll notice that 156 through 158 is actually the same as 149 through 151. But what I'm doing is wrapping this in a task run. I've also copied in that assertion right here, and that's because you may want to ensure right in your splash screen and not in the calling destination that you are checking for this, right? It's not the responsibility of the person who's implementing the background loading to know that. You really want to guarantee it for that person. So I have this now copied into here as well. But what this should afford us to do is go run this work in the background. We're guaranteeing it here, right? But this task run is what's going to be the thing that allows us to do that. So I'm going to go ahead and run this now, and we'll see if that gets us any further. I've entered, I hit my breakpoint. I'm just going to press F5 and hopefully we can get down to here. Oh, and we get a splash screen, which is awesome. But now we hit another breakpoint. So let's go and we hit another exception. So that breakpoint we hit, we ended up hitting that because the work finished. To explain why it finished or how I know that it finished successfully is that this does 50 iterations waiting for 50 milliseconds. And that means we're going to wait for 2.5 seconds overall. So after 2.5 seconds, if I scroll back to here, we finished this, right? We finished that, we got to this line, but when I tried to get this Windows style, it actually threw an exception. And you'll see now that I have this other exception going on because this part up here is also throwing a similar type of exception. It's happening because we're on the wrong thread. This one, we're going to come back to in just a moment. This is a bit of a distraction. It's just because this was all asynchronous. I'm trying to record the video. My editor's going to have a hell of a time trying to get this all put in order, but this part down here was what happened first. As soon as I stepped over it, it threw an exception. So if I stop this, why is this on the wrong thread? And it might not be obvious to you, but it's all because of line 154. So I'm going to talk about this for just a moment. We ran this task, right? This forced the background work to actually be on a background thread instead of the main thread. That's good for us. But configure await. This is something that you probably see in a lot of spots when you're using tasks. Configure await false means that when this task finishes, we don't care which thread it resumes on. This task started on the main thread, and we said we don't care which one after. Now, if I take this away, this will mean that this execution flow will resume back on the main thread. That's where it started. And that means that this should be safe for us. The other way that you could go do this is that dispatcher that I talked about earlier. We could use the dispatcher, and I have it as _dispatcher. We could go do this and then put this code inside here. This is one option where you don't need that. So that's one thing you could do. Or we could take this out and we could not use this. By not having configure await false, this will go resume back on the main thread. Let's go prove it. So there's our breakpoint being hit at the beginning. I'm going to go put the breakpoint here. So after this goes and executes. 2.5 seconds in, and we get over this line successfully. And that's because we are still on the main thread. So that's what doing this helped us with. Is everything okay? Or are we still going to have this problem that came up as well? It's the same issue. We are not on the main thread when we go to finish this maximum wait time, right? Let's go fix this with the dispatcher. This is the other thing I said we could do. In this particular code, unlike the configure await thing that I was changing before, I'm going to use the dispatcher to say, hey, look, I want you to go run this body of code inside of this anonymous delegate. I want you to go run this code on the main thread for us. Let's go try this in combination with what we had before. And I'm going to go ahead and take this breakpoint off, and as well this one down here, because I want to see if this flows all the way through to the end now. After 2.5 seconds, we should get that X in the top right, and there we go. It closed off automatically after a total of 5 seconds, and we got our main window. So far, so good. Right? We ended up switching between the state of the window. It automatically closed off after 5 seconds. So that functionality seems to be working for us. But there's still one more thing that we have to prove. And that's if I click that X while it's running. So let's go run this again. After 2.5 seconds, I should be able to click the X. And it works. And if I wait the rest of that sort of 5-second period, there's no exceptions, no crashing. Nothing weird going on. So to recap, what we have going on here is a splash screen that we can go use through what I'm calling a presenter. So a splash presenter. You can do this in any way that you want. This is just my preferred way, again with some dependency injection. I have to hook up an event for when that window is closing, because once it's closed, that's when I want to launch the main form. And the big things that we wanted to look through in this method were that we wanted to wait a period of time. And then the other thing was running some background work truly in the background. Between these two things, we wait for them accordingly, and then we're going to switch the window style. And this is where I said you could do some other things like putting buttons up. You could click on the user interface, make it enabled instead of disabled, anything you want there. But that's line 162. We do that after the background work is done. And then finally, we wait for that wait time to finish off. In between all of these things, if the user clicks and tries to close it off, it should go work successfully. So to go run this one more time, we should see this all come together. We get this little progress bar that's indeterminate. We got the X in the top right, and it closed off on its own. And that is how you go make a splash screen. But I did promise you at the beginning of this video that if you wanted to see how we could go get progress to work on our splash screen, that you had to watch to the end. So if you wait, when this video is uploaded, you can see how to do that. Thanks, and I'll see you next time.